Here we are at the end of Module 1. This is our last section for our first of 4 modules. So in this section, we're going to learn about least common multiple, or LCM, and greatest common factor, or GCF. So the first one, Ren and Larry are running around a track. Ren can run 1 lap in 3 minutes, while it takes Larry 4 minutes. If they both start at the same time, how many minutes will it take for them to meet? Back at the beginning. So Larry, well, let's see, which one's which? So Ren is 3 minutes. So Ren will be at the start at 0 minutes, of course. Then she'll be at the start again at 3 minutes, because it takes her 3 minutes to run a lap. Then she'll be at the start again after 6 minutes, and 9, and 12, and 15, and 18. So every 3 minutes she will be at the beginning where they began running. Larry takes 4 minutes. So Larry will be at the starting point again at 4 minutes, 8, 12, 16, 20, 24, and so on. So every 4 minutes, Larry will be at the beginning where they started. So to find the LCM, we go down the list until we see the same number. So 3, nope, 6, nope, 9, nope, 12, ding, 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 ding. So there is our LCM. So after 12 minutes, so they'll both start running. And then after 12 minutes, they will reach the starting point again at the same time. So that would be 12 minutes, and 12 is the least common multiple, which means the first number they multiply into together. So hence the name multiple. So when you see multiple, think, oh, it's the first number that both numbers go into evenly, and you get to it by multiplying. You multiply 3 by 4 and 4 by 3. How many minutes after the starting time will they meet for the second and third time? So that's the cool thing about multiples. Once you have the first one, then you take it times 2, and they'll meet again in 24 minutes. So 24 minutes from the beginning, or 12 minutes after the first time they meet. And then for the third time, 12 times 3, 36 minutes. So they'll meet for the first time after starting at 12 minutes at the starting point, and then again in 24 minutes, and then in 36 minutes. So every 12 minutes they will meet. Suppose their friend Sarah decides to join them, and it takes her 5 minutes. If they all start at the same time, how long will it take them to be at the beginning? So let's do Sarah here. And she is every 5 minutes. So 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6, so just keep adding 5, 35, 40, 45, 50, 55, 60. Okay, so let's look and see. So is 5 in that group? No. 10? No. 15? No. 20? 20's on this one. We haven't done enough on that one, so we're probably going to have to extend Ren and Larry. And I'm going to show you an easier way to do this that's not quite so time consuming, but first we're just going to use this listing method. So we see that at 20 minutes, nobody's met yet. So let's start on the next one. So add 3 to Rin, and we get 21. Add 3 more, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60. And then Larry, we got to pick up after 24. So we have 27, 30, nope. I started counting by 3s for Larry. Larry goes by 4s, so 28. So I'm just adding on to Larry's last time. Add 4 more, 32. Add 4 more, 36, 40, 44, 48, 52, 56, 60. Okay, so now we have a good list. So 20 was in Larry, but 20 was not in Rin. So next we have 25. 25 is not in either list. 30 is in this list, but not this one. 35 is in neither list. 40 was in this list, but not this one. 45 is here, but not here. 50's in neither of these. 55, neither. 60, finally we found one that's in all 3 lists. 60, 60, 60. So they all 3 will not be at the starting point until 1 hour after they began, and then they'll meet up again at the start. So the LCM is 60, the smallest number that they all go into by multiplying. 5 times 1, 5 times 2, 5 times 3, just like we did 3 times 1, 3 times 2, and so on. So you can see when we add a third number, it gets pretty busy, and this takes a long time to do. So on the next pages, I'll show you a little bit simpler method to do that. Okay, so if you want to shut off the recording and try this one on your own, this is a good one, not too hard, pretty easy. So good one to practice on. So hot dogs are sold in packages of 8 and buns are sold in packages of 12. Okay, so join me after you work this one out and we'll see how you did. So what is the least number of each you can buy so you have the same amount of hot dogs as buns? So hot dogs are sold in packages of 8. So 8 times 1, 8 times 2, 8 times, whoops, now I'm writing 8 times 3, 8 times 4, 8 times 5, 8 times 6. So we'll see if that's enough. And then the buns are sold in packages of 12. And so we have 12 buns or 24, and boom, I already got a matching number. Woo, that one was nicer than the last one, huh? So we have to buy 24 hot dogs and buns. And sometimes when you're doing this in Alex, they ask you for the number of packages. So 1, 2, 3, that would be 3 packages of hot dogs or 24 hot dogs, depending on how they ask. This one's kind of vague. What is the least number of each you can buy? So least number of hot dogs or least number of packages? Kind of vague. So we got both our bases covered. If they ask for packages, it would be 3 packages of hot dogs or 24 hot dogs. For the buns, it would be 2 packages of buns. Or 24 buns, depending on which one they ask. So 24 is the least common multiple. It's the smallest number. They both multiply to go into evenly. So always think of M for multiply. It's going to be a number larger. Well, the smallest it can be is the size of the largest number. So 12 could be the smallest, but it didn't work. So it's going to be either equal to the largest number or in this case larger than both. If I need at least 35 hot dogs, how many packages should you buy of each then? So let's just bring our list down here, and we have to go past 35. So 8, 16, 24, 32, 40, 48, and we're going to have to bring this one out some more. So buns, 12 times 1, not in the list. 12 times 2's in the list, but I need at least 35. 12 times 3 is 36, not in the first list. 12 times 4 is 48. Ding, 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 ding. There we go. So if they can't buy less than 35, then 48 would be the next smallest common multiple. It wouldn't be called the least common multiple because that's 24, but it would be the next smallest common multiple. And we could have also just taken 24 times 2. So that would be 48 hot dogs, or if there's 8, that would be 6 packages. Because 8 goes into 48 6 times, and 48 buns or 12 goes into 48 4 times, so that would be or 4 packages of buns. And there we have it. So once you find the first one, you should see a pattern here. You can find the next one just by taking it by 2, just like we did up here. Once you find the first one, you can find the next one by taking it by 2, and the third one by multiplying it by 3. So we established a pattern there. Okay, so that's called finding the least common multiple using the listing method. You list out the numbers till you find a number that's common in both. And it does have to be the smallest. I've seen students make their list perfectly and then circle one that's not the smallest. You go from smallest to largest until you find the first one they have in common. That's why it's called the least common multiple. Okay, let's see what's on the next side. We're going to talk about factors, and we're going to use rectangles. You might want to have a highlighter for this. It makes it a lot easier. You could outline it in a different color, whatever. So 15. How do I get 15 square units? And they have to be whole numbers, no fractions or decimals, it says in the directions. Then write the corresponding multiplication problem and list the factors. So 15 can be 3 by 5, or it can be 1 times 15. So here's our 2 multiplication problems. 3 times 5 is 15, 1 times 15. So that means the factors are 1, 3, 5, and 15. Those are all the numbers that go into 15 evenly. 1 square unit, well, the only way to get 1 is 1 times 1. So like I said, you can either use a highlighter or a pen on that. So 1 this way and 1 this way, so it would just be 1 times 1 is 1. That's an easy one. And so the factors of 1 are just 1. That's it. We wouldn't list it twice, so the only numbers that go into 1 is 1 itself. 2 square units, another pretty nice easy one. The only way we can get 2 is doing 1 times 2. So 1 unit by 2 units. So the multiplication would be 1 times 2 is 2. The factors of 2 are 1 and 2. Those are the only two numbers that go into 2 evenly. And 1 goes into every whole number, so 1 should always be your first number. And then you list the other numbers from the group. Okay. We have 3. Oh my goodness, 4, 5, 6. So let's do 3 more together, and then you guys can do the 3 on the next page. How about that? So we haven't really had any fun ones here. I guess there's not really any fun ones on this page. These are all kind of boring, but oh well, we'll deal. So 3, the only way to get 3 is 1 times 3. Nothing else goes into 3 besides 1 and 3, so we have 1 times 3 equals 3. So that means the only factors, the only numbers that go into 3 evenly are 1 and 3. Okay, 4 is a little bit more fun. 1 times 4 is 4, but so is 2 times 2, so we'll have 2 here. So 1 times 1, 2, 3, 4. And then also 2 by 2. So those two equations would be 1 times 4 is 4, and 2 times 2 is 4. And the factors of 4 would be list all the numbers you see. I see a 1, a 2, and a 4, and we never repeat numbers. So the 3 numbers that go into 4 evenly are 1, 2, and 4, and they're called the factors of 4. Okay, same thing with 5. 5, the only way to get 5 is 1 times 5. So we have 1 here, and 1, 2, 3, 4, 5 here. So just one equation, 1 times 5 is 5, nothing else goes into 5, so its only factors are 1 and 5. And we're going to learn on the next page the definition of prime and composite. Prime numbers are numbers that have only 1 and itself as factors. So this would be prime, and this would be prime. Composite numbers that are numbers that have more than 2 factors. So this would be composite because it has 3 factors. So if it only has 2 factors, it's prime. If it has 3 or more factors, it's called composite. Prime means nothing goes into it but 1 and itself. And we'll have the formal definition coming up. Okay, so there are, wow, 1, 2, 3, 4, 5 more of these. So let's do 2, and then you can do the last 3. 6 square units. Well, 1 goes into everything, so we can start with 1. So it would be 1 times 6. 1, 2, 3, 4, 5, 6. But 2 goes into 6 as well. 2 times 3 is 6, so we'd have 2 times 1, 2, 3. Both of them I will end up with 6 blocks. So 6 blocks this way, 6 blocks that way. Nothing else goes into 6, so we have 2 multiplication problems. 1 times 6 is 6, and 2 times 3 is 6. And then I list each number once for the factors in order. 1 goes into everything, 2 goes into 6, 3 goes into 6, and of course the number itself goes into 6. So 6 has 4 factors, therefore it is composite. So any number with more than 2 factors is composite. Okay, one more, then it's up to you guys. So 8 square units. So we can all 1, 2, 3, 4, 5, 6, 7, 8. So we can start with the obvious one, 1 times 8. And then 2 goes into 8, 2 times 4. 1, 2, 3, 4. Nothing else goes into 8. So it looks like 8 has 4 factors and is also composite. So 1 times 8 is 8, and 2 times 4 equals 8. So its factors are 1, 2, 4, and 8. Remember, factors are numbers that divide evenly into the given number. Okay, the next 3 are yours. You have H, I, and J. So go ahead and turn off the video and work on those. See if you can find all the factors, and then start it back up and we'll check your work. So we'll start with the obvious one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 times 12 has 12 square units in it. And then I just go up the line one at a time. 2 goes into it, so that would be 2 times 6 is 12. 1, 2, 3, 4, 5, 6. And I can also see there's 12 square units in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2 by 6. The next number after 2 would be 3. 3 goes in 4 times. So 1, 2, 3. 1, 2, 3, 4. And you can see again we still have 12 square units. 4, 8, 12. So all of those contain 12 boxes. So we got 1, 2, 3, 4. 5 doesn't go into it, 6 does. So that's it. So there's 3 sets of factors for 12. So 1 times 12 is 12. 2 times 6 is 12. 3 times 4 equals 12. And the factors in order: 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12. So those are all the numbers that divide into 12 equally. Because there are more than 2 of them, that means 12 is a composite number. All the numbers on this page are composite. More than 2, more than 2, more than 2 factors. So we have 3 composite numbers on this page. Okay, let's see how you did on these last 2. So 13. So what do you think? Can you guys think of any numbers that go into 13 besides 1 and 13? I know I can't think of any. So that means because 13 only has 1 set of factors, it is prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 1 times 13 is 13. It only has 2 factors, making 13 prime. That means nothing goes into it except 1 and itself. 16. Ooh, we might have quite a few in that one, huh? So 16, we have 1 and 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 square units in that one because each box is 1 square unit. Then we go up from 1. Does 2 go into it? Yes. 2 times 8. 1, 2, 3, 4, 5, 6, 7, 8. So there are 16 square units in that as well. 8 plus 8 is 16. And then we have 4 by 4. 3 doesn't go into 16, but 4 does. So 1, 2, 3, 4. 1, 2, 3, 4. So 4 by 4. So 16 has 1, 2, 3, 4, 5 factors, making it composite. So we have 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is 16. And listing the factors in order, 1, 2, 4, 8, and 16. 1, 2, 4, 8, and 16. Yep. Here we go. So those are all different ways to find 16 square units. In other words, we're just finding factors of 16, the numbers that go into it evenly. Okay. So here's our formal definition. So a prime number is a number greater than 1. So notice the verbiage. A number greater than 1 whose factor pairs are only the number itself and 1. So let's use a highlighter because that doesn't stick out too good. So prime number, it has to be greater than 1. And it only has 2 factors, 1 and itself. Composite number is also greater than 1. And it has, I like it better when they say more than 2 factors. So let's do that. More than 2 factors. That's the definition of composite. That's easier than saying which has factors other than 1 in itself, so more than 2 factors. Better way to remember it. So they want us to list all the primes from what we just did. So problem B. So why did they tell us to start with B? Does 1 have 2 factors? No. And do you remember that both of their definitions said a number greater than 1? So guess what? 1's not anything. It's not prime, it's not composite. Same with 0. So 0 and 1 are not prime, not composite. Every other number is 1 or the other. No way you can be both. But that's why they told us to start with B, because 1 is neither. So 2 was prime, 2 factors. 3 was prime, 2 factors. Nope. 5 was prime, 2 factors. So let's write those first ones down. 2, 3, 5 in the prime section. And then on the back, more than 2, more than 2, more than 2. And on this page, okay, is that it? Oh no, I had one. Wasn't there another page? I feel like I'm missing one. Said B through J. H, there must be an, oh, it's on this side. There we go. 13 was prime, only 2 factors, but 16 wasn't. So 13's the last of the primes of what we did. Okay, composite numbers. So only 2 factors, not composite. Only 2, not composite. Oh, there's our first one. So that was 4. So memorize these. This one's prime. Oops, here's a whole bunch of composites. 6, more than 2 factors. 8, more than 2 factors. 12. So 4, 6, 8, 12. So these all have more than 2 factors. And then there was one on the last page, which was 16. So those are all the numbers from our list that we just did. Prime, only 2 factors, only 2 factors, only 2, only 2. All these composites had more than 2 factors. 0 and 1 are neither prime nor composite because they are not greater than 1, as the directions said. Nor composite because they are not greater than 1. So 0 and 1 are neither prime nor composite because they are not greater than 1, which the definition in both requires. Okay, that looks like a good stopping place. So we'll stop there and pick up on student page C. See you in a bit.